This is Chapter 8, Right Triangles and Trigonometry. This can be a challenging chapter, considering trigonometry used to be a whole math course in itself, separate from geometry. Now they're combined. Try the warm-up problems, pause the video, and check your answers when you're ready. Here's your answer to the warm-up problems. Remember, when we take the square root of a number, it could have been plus or minus. So in number 5, it says plus or minus 5. But in geometry, we're usually talking about side lengths or angle measures or things like that. So when we take the square root, it's going to be the whole number because we wouldn't have a negative side or angle. So the altitude is like height. So if we're looking at the altitude CD right here, the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original triangle. So all three end up being similar to each other. Write a similarity statement comparing the three triangles. So notice that I redrew all of the three triangles that we would see in our shape over here on the right. So these are all redrawn. And when I drew them all, I made note to myself, I should have marked it on here, of all the right angles. And then I also noticed all the smaller sides. That helped me to make sure that I was lining things up correctly. So all of my small sides are lined up together, like WV, which matches ZW, which matched the other ZW. All my right angles match, which were the Z, Z, and W. So you have to keep in mind that when you're writing this, you need to line things up properly. For the now you try, for the first triangle, triangle SPR, so I'm looking at the smaller triangle first. The PR is the smallest side, so I'm just kind of keeping this in mind when I go to write my next triangle that it's similar to. So if I look at the medium-sized triangle now, my smallest side is PS, so I know that's going to be at the end. So it's going to go T, P, S, and I'm double checking that the P was lined up with the other P since they're both the right angles, and that's correct. Is similar to triangle. Now we're looking at the large triangle, so let's erase what I have in here. We're looking at this large triangle here, and I notice that the smallest side of that large triangle is right here, RS, so I know that's what I'm going to end with. But S is actually my right angle, so that will go in the middle. The R, SR is the smallest side, and the T. Imagine we have a list of numbers such as 2, 6, 18. How can we get from one number to the next? In this case, we'd be multiplying by 3 for all of them. 2 times 3 is 6, 6 times 3 is 18. Now imagine we have the same list, but we don't know the middle number. 2 blank, we'll call that X, 18. How can we determine that middle number? Well, we can use what's called the geometric mean. Geometric mean takes that first number, puts it in the top left, the bottom number put it in the top right, and has X in between. And this is a proportion that we would solve by cross multiplying. So it would be like 2 over X equals X over 18. And then we would cross multiply and we get X squared equals 36. To solve for X, we'd have to get square root to cancel the squared. And we get X equals 6. And notice that was the answer in the original one. So in order to find geometric mean, we're going to use that formula each time. It's going to be the first number over X equals X over the next number. Cross multiply, so we get X squared equals 100. Solve for X by square rooting each side, and we get X equals 10. Okay, 5 and 30, so it's going to be 5 over X equals X over 30. We end up with X squared equals 150. Square root both sides, and since this is not a perfect square, we have to do some simplifying. So I'm going to just simplify it over here. 10 times 15. 10 is 5 and 2, and 15 is 5 and 3. So the 5 comes out, and the 6 from the 2 times 3 goes inside. The 5 came out, 2 times 3 on the inside. So 5 radical 6. Find the geometric mean of the pair of numbers. So you can try this if you want. Pause the video, and when you're ready, hit play. Here's the answers to the now you try. 6 and 3 radical 10. So what was the point of that? Well, this is what we use This is how we use it in geometry. So we can use that theorem to write proportions comparing the side lengths of triangles formed by drawing the altitude to the hypotenuse of the right triangle. And so there's a bunch of formulas here, and I'm going to try to simplify them for you. Keep in mind that the altitude is this h right here. So this first one is saying altitude squared equals base times base. Little base times big base, I guess we could say. X times the y, right? And then some other formulas that we have is if you look at the a squared, so the is like the little hypotenuse over here, going with the little, it's the smaller of the two triangles. So I call that little hypotenuse squared equals little base, or its base, times the total. So little base times total base. And then the b squared, I call that big hypotenuse squared. It's the side one. Let's do it in a different color here. Big hypotenuse squared. Big height squared equals its side, its base, I mean, base times the total base. So maybe those will make more sense to you, because you're not always going to have these A, B's, H's, and things like that. You do have to know what the altitude is and what I'm referring to when I'm calling it by little base and big base and little hypotenuse, etc. So let's see, in this first example 3, I see that my altitude is 6. So the first thing I can do is altitude squared equals base times base. What that means is 6 squared equals the base, which is 9, times x. So 36 equals 9x, divide both sides by 9, and we get x equals 4. So now I have my little base. So since I have that, I could do, let's see, little hypotenuse squared equals base times the total base. So little hypotenuse squared would be the smaller triangle. I'd call that y squared equals base, which is 4, times the total base. Well, the total is 13, 9 and 4. So y squared equals 4 times 13, which is 52. And then square root both sides, so y equals radical 52, which we can simplify to be 4 and 13, 2 and 2, so 2 radical 13. So that's what the y is, 2 radical 13. And now we can do the same thing for the z. Notice it's the large hypotenuse. Let's change the color. I'll do it in black. The big hypotenuse squared now, so that would be z squared equals its base, which is 9, times the total base, which is 13. So z squared equals 130 minus 9, 121. That can't be. 3 times 9 is 27. 9 times 1 is like 10, 11. 117. Okay, and then square root both sides. So z equals, and this can be simplified to 9 times 13, which is 3 times 3, so 3 radical 13 is z. And you could check your work using Pythagorean theorem for any of these. Okay, for the now you try, I'm going to walk you through this one. So remember that altitude squared equals base times base. So I've got my altitude is x. So x squared equals 2 times the other base of 10. So x squared equals 20. Square root both sides, and then we have to simplify. 2 times 10, 2 times 5. So the 2's come out and the 5 stays inside, so x is 2 radical 5. So that's my altitude, 2 radical 5. And now I can go to my next one. My next one would be little hypotenuse squared. Well, here's my small triangle, and my hypotenuse would be z equals the base, little base, times the total. So little base is 2, and the total here is going to be 12. So little hype squared, z squared, equals the base, 2 times the total, which is 12. Z squared equals 24, square root both sides, and z equals, we have to break down this 24, which would be like 6 times 4, 3, 2, 2, 2. So a pair of 2's comes out, and the 6 goes in. So z equals 2 radical 6. And the last one would be like the same idea, but now it's big height squared. Well, big hypotenuse in this case is y equals the base times the total base. So that would be y squared equals 10 times the total base 12. Y squared equals 120, square root both sides, so y equals radical 120, but we gotta do a factor tree. So we get 3, 4, 2, 2. 3, 2, 2, 2, 5. So a pair of 2's comes out. And inside we have left a 3, 2, and a 5. Well, 3 times 2 is 6, times 5 is 30. Okay, so here we're given the altitude is 7.8, so we could say 7.8 squared equals base times, we don't know the other base, 1.6 times x. And 7.8 squared, 60.84 equals 1.6x. Divide both sides by 1.6. It's 38.025. Okay, and then we need the total height of the tree to the nearest meter. So what that means is that we have to add the 1.6 to it. It's 38.025 plus 1.6 is 39.626, but we need to round to the nearest. So that would be 40 meters. About 40 meters. For the now you try, I recommend that you convert to inches like we did in the last chapter. This is very similar to the problem we just did, but I ended up with about 47 feet. Meters, so I would